Now we'll go through the slide again in a second. It will be common in this section. I'll show you why it's very easy to us. Or sorry, where it is easy for us. How many x's is this? 5x, and it's no problem to us whatsoever. But to actually kind of prove it mathematically, now you might say it's overkill, but anyway, to prove it mathematically, what you do is there's one thing you do is the order multiplication doesn't matter, so it's x by 2 plus x by 3. Then you take out the common factor of x. And what's 2 plus 3? 5, and then we write x by 5 is 5 by x. Now obviously that would be completely daft. But actually this is what's going on. Now usually this bit from here to here is really easy. What would you describe this as going from here to here?
Factorization? Or the other
way?
Yeah.
Multiplying out? What? Expanding, yeah, expanding, multiplying out. That bit is easy. X by 2 plus x by 3. It's going the other. We're just doing that in reverse. So you're taking, like if you were to multiply this out, you'd have 6y by dy dx plus 1 by dy dx. You'd have exactly what we did. So you're just doing that in reverse. And when you do that, now you can see what you need to do to get dy dx on its own. Divided by that. Yeah. So most of us don't see that. I include myself in that, definitely. Now, does anybody want to ask again about this? It's actually no different to just doing 2x plus 3x is 5x. It's just a bit harder for us because there's 2 plus 3. That's very natural. 6y plus 1 is a bit harder. Okay, so this is, and then we're dividing both sides by 6y plus 1. This is the slope at any point, and all we're asked for is the slope at 1 minus 1. So all we have to do is substitute in 1 minus 1 and we're done. Then we get 6 by 1 squared, 6 by minus 1 plus 1. 6 over minus 5. You had a bit of fun with this one earlier. What's this to say us? It's perfectly fine number as it is, but what would we normally write this?
Minus 6 over.
Minus 6 over 5. And it's negative like we thought. Now that question wasn't looking for any more. I will.
You just treated the dy dx back up along with the x in this equation over here. Yeah, that's all you do.
Yeah, very similar. Yeah, very similar. I might go back to the third one. We'll look at the. We may go back to question 3. Yeah, we may go back to question 3. We'll look at example 4. On the bottom. So this one's going to be a little bit. Why is this one a bit harder? Say again? 3. There's 3 of them. Yeah. Now it's a sum, so it's okay. We can differentiate them separately. And the y squared we've kind of dealt with. The y cubed we can deal with. What about the one in the middle?
X, yeah. 3xy squared, like.
You can talk about brackets if you want, but what's the headline? I think some of you saying it. Product. It's 3x by y squared. Okay, so use implicit differentiation to find the equation of the tangent line to this curve. If you're very bored, you can go on, there's a website, Work from Alpha, and just start banging in equations and it will draw curves for you. And there's people who can draw Batman curves and everything with them. Or any, whatever you want to draw. You can get all kinds of shapes. Okay, So this is the curve we're looking at, and we want to get the equation of the tangent line at that point. So as soon as I see line, I'm writing down y minus y1 equals m times x minus x1. So we have the point, we need to get the slope, and all day long the slope of a tangent is dy dx, and I'm recommending that you rewrite it, the original equation, or the equation of the curve, which instead of y, y of x. So we're talking x squared plus 3x times y of x squared plus y of x cubed equal to 5.